Welcome to primitive data types. And before we get to understand what primitive data types are, I will have us know that Java is statically typed. And this will help us understand why it's important to know about data types or primitive data types in this case. So by statically typed, that means that before you get to use a variable, you have to specify that this variable expects a value of this type of data, and it is checked during compile time. So this is what I mean. If I was to write variable example and I equate it to 5, then that will not work because Java does not recognize what this is. I have to specify that it is of type int, meaning it is expecting me to store integers into the variable example. If I try to attach anything else, like a string value for example, then it will error out because it is expecting an integer. And it is checked at compile time, which is why even before I run the code, you get to see the error right there and then during compile time. So that is what statically typed means. Variables are explicitly declared and they are checked at compile time to enforce type correctness. Now, an alternative to this is dynamically typed. So if there are languages out there that are dynamically typed, you can just write the variable name and then you proceed on to use them. Those usually confuse me very much. Maybe one day I'll get used to that, but I'm so used to statically typed kind of programming language. But if you're coming from a dynamically typed, then you probably see the difference between Java and your dynamically typed language. So this is the syntax. Data type could be int, could be let me work with primitive data types. As you will see here, it could be long, could be float. Then you give it the name, then you can initialize it. Okay, we talked about fields and variables, or rather fields, different types of variables, fields included, and how it's not a must for us to initialize fields, but it's a must for us to initialize local variables. So data type determines the value that will be stored. Once again, if it's an integer and I attempt to store a string value, it errors out. That is the importance of data types. And with the statically typed programming language, then we understand the importance of understanding primitive data types. So there are 8 of them. Please feel free to screenshot this and use it either now or later as a review. I made a table with I'll just walk you through it very briefly. So byte is the smallest one, and I've indicated why. Short follows int, long, float, double, boolean, and character. Those are the 8 primitive data types in the Java language, and they each have a default value. So if you're working with a field, and by now if you've been keen in the previous sessions, you know what a field is. So if you're working with a field, then this would be, if you don't initialize a byte, then it will be initialized to 0 by default. Same applies to short, int, and then if it's long, I will usually use L to self-document, to be very certain that this is a long value. You use capital L. Small l is supported, but small l looks like a 1, so it's preferred that you work with capital L. Floating and double. So floating and double are used when you're working with decimals, but please note, don't use it for precise values like currency. With currency, we have a big decimal class that you can work with. So F for float, D for decimal, for double. If you work with what do you call this? If you work with decimal points and you don't indicate F or D, then the default is usually a double. A boolean is false, true and false. Then we have the character ones. So you can screenshot this, refer to it, try and understand it some more if it interests you, but these are the primitive data types. So people work with say byte when they don't want to work with big values and they're certain of it, and to save on space, they usually work with bytes. Others have argued that it's okay to just work with integers through and through, doesn't matter, so it depends. Sometimes you might find that you have a functionality that will require you to work with short, but more often you just work with integers and so on. So you can look at it, get to understand some more, and I'll also attach a reference link in the description. So string sometimes is confused to be a primitive data type in Java because it's given so much support, but it's not. It's actually an object. So unlike other objects where we talked about how you need to initialize them with a new keyword, for example, object type, which is what we already covered, object name, then initialize it with a new keyword, then continue on with the object type and so on. So with a string we don't do that. So sometimes you might assume that it's a primitive data type, but it actually isn't. We will be talking more about strings later, but I had to bring it up here because I even use it in the example. So when I work with strings here, string type, and I type 5, it is erroring out in compile time, but I can store a string value and that will be fine. So it pretty much operates like a primitive value, but it isn't. We'll talk more about that in a later session. So, and its default value is null. Null, as you see, is not used to primitive data types, but it applies with objects such as string, you're seeing there. Okay, so there you go. Now about initialization. So if it's a field such as this, int uninitialized, I can use it like that. Another primitive data type, say char and init, and so on and so forth. So with this, default values will be applied. However, if you're talking about a method within the confines of a method, it's not possible to do that and have it attach the default value. So an init one, if I do that and I attempt to use this, it will not apply the default value. What will happen is I'll get an error. Okay, so if I try to, for example, I want to see how that works. So if I try to use it, 1 plus not init, you'll see that I get an error because again I haven't declared it, so I have not initialized it, and because it's a local variable, the default value does not apply. However, if I was to work with the uninitialized value field uninit up here, then it will automatically apply the default value. And if this was an int, we expect that default value to be 0, so this should be a 1. And that is that. If you want to know more about this, I've attached this link in the description. Look through literals, the literal value that you give you assign to your primitive data types, variables, and you can look at integer literals. There are several supported. There's a decimal type, there's the hexadecimal value, and the binary type. So you can look into that if you're curious about that. We also have floating point literals and how the different types that are accommodated, like with the floating point with the f appended, the double, and the scientific notation. Then we have character literals and some of the special escape sequences, like this one is for backspace, this one is for tab, and so on and so forth. But also look at working with underscores with nice examples on how to do that. For example, if you're working with very long numbers such as this, you might opt to work with underscores as you would with commas in a normal sentence, or in long bytes such as this, and so on and so forth. So there's examples here on where it's acceptable to work with underscores and where it is invalid to when you work with underscores. So if you want to know more about that, you can check out the link in the description. See you on the next one.